everyone, I'm Natasha and welcome back. So today we're gonna, continue our chapter number 2, relations and functions. So, in the last video we discussed about relation and the domain, range and codomain in relation. And we're also going to discuss these three same topics: domain, range, and codomain in function. So as we're on a topic function, so in today's video we're going to discuss about function. So function is kind of a really important topic that is covered in maths, like that we're going to discuss in maths. So let's get started. Okay, so the first thing about the function is that how can I express the function, what is it exactly? So in science, if we're going to talk about the function, function is kind of a what's its job, what's its work, function of our eye, function of our function of our heads, and all those things. If I'm going to talk about the function inside. But we're discussing function in maths. So in maths, function is kind of different. So yeah. So function is kind of a thing which in which way okay. So the maths in this chapter we discussed about two things. If we have talked about these two things, input and the output. In the relation also, so the input we give and the output we get. So I'm going to draw something right here. Really, it's going to be related to function. Sorry. Yeah. I was saying that let's say I have a machine. This machine looks like this way. It's too narrow. Yeah. So let's make it really simple. Wait a second, let me just rub it, and I'm going to draw it a little different way. Okay, so I'm back, and let me draw it again. Okay, so it's like a machine that I'm going to draw right now, so which has two entrances. First one the entrance, and the second one is going to be the exit. We have entrance, and here we have the exit one. Okay, this is kind of a machine. So this is function, and here we have the output that we get. This is what we'll call output, and the things which we'll put in it we'll call them input. Okay, so something in the function, we put the input, we're gonna get the output. So the process between the input, in the input to the output we get. So let me take an easy example. Okay, so let's say if we're gonna say 2 square, if we're gonna put the 2 square as the input, what are we going to get? I'm going to get the output 4. I'm gonna get the output 4 through this function. So functions is like just basically say, take like if I'm going to say this f of x squared. So what it just did was the x squared was the 2 squared, and it gave me the output 4. Yeah, what it did. Isn't it? So like f of x, f of y, or if it can be like anything. That was just for example, okay? That was just an example, nothing else. To just tell you a little bit about function. Okay. I'm almost done. Yeah. Okay, so now let's finally talk about the function. Like, let's say we have two sets, set P and set Q. And let's say we have element X and element Y. So the element X is in set P, and element Y is in set Q. So for the function that I'm going to say, that the function represented by the letter F, which we say F from set P to set Q is this particular, is a particular kind of relation for which every element X consists of one and only one set. It's not a set, like I'm talking about the element. So one and only one element Y, which is in set Q, isn't it? So mathematically, like how we're going to write it. So it's just like an easy way. How I'm gonna write it. So it's gonna be sorry. Yeah. So f the function and the set P in the set Q. If you know about this side, like I've already talked about the symbol, and if you know about implies, okay. So what it is the function set P and the set Q. The statement which I just said, it's just related to it. But yeah, it's just a different way to write it back, because mathematically it's just kind of different. We're not going to write the whole statement. So, where f of x is equal to y. So what is it trying to tell us? That the function of element x, and the element x is in set P, and element y is in set Q. So what is it trying to tell us? It is trying to tell us that the function represented by the letter by the letter F from a set P to a set Q, and and which is a particular kind of relation for which every element X consists of one and only one element Y, which is in and element Y is in set Q. So mathematically we're going to write it like this way. That's it. So functions like basically telling the relation. So I can say the function is kind of a special relation. So yeah, we can say that function. What is function? So I can say that it is a special kind of relation. Yeah, it is actually like a relation, type of relation, but it is a special kind of relation. Yeah, if I were to talk about a function in this chapter, okay? Like, yeah, most of the time, like, we're going to use function like most of the time, like we will use function in like in trigonometry. Trigonometry is common for all of us, and like there are a lot of topics in which function will be used. So this is the important time that we should understand everything about function clearly. Okay, so have you heard about trigonometric functions? That's what it is. So and in that topic also we're going to discuss about function, but yeah, in a different way. Okay, let's just forget about the other things. Let's just focus on only the basics of function that we're going to just discuss about. Okay, so the next thing is that if I'm going to take another sets, let's say I have set A and set B. Okay, so what I will say is that relation F of set A and the set B we have as a relation F and the set A and the set B is a function if every element wait a second. Yeah, I was saying if every element in A has a mapping. What does mapping means? Mapping is kind of, mapping is just say for the function, or we could say mapping, it is used for the function, okay? And the second thing that not every. Okay, let's start it from every, okay? So the second part is going to be every element in A has a unique mapping. Okay, so what does these two statements mean? These two statements are almost the same. They have just a little difference. What is the difference? So, and what did I write? All the things that I just wrote. What does all that mean? So a relation F is for the function that I've already said. And instead of set P and Q, I chose set A and B. So set A and B is considered. Is considered a function if, okay, so only two sets can be considered a function if every element in the first set has a mapping, and every element in the first set has a unique mapping. Yeah, so I was saying that it has a unique mapping. So what does that unique mapping means in the normal mapping? So mapping is that it is just trying to say is that every element in set A has a mapping. Mapping means a function. So it is trying to say is that every element in set A should have a function. Okay, they should have a function, and every element in A a unique mapping, which means they should have a unique function. Like unique means like a different, isn't it? So let's take an example. So okay, let me take an easy example, and I'm going to use the arrow diagram. Okay, which is right here. I'm going to draw two circles. Yeah, I can say these are circles. Okay, the two circles I have right here. First one is set A. Second one is set B. So let's say that okay, so let's say I have the elements 1, 2, 3, and 4 in set A, and in set B I have let's say X, Y. Okay, let's take something else. Okay, because I usually use X and Y as the elements. And as a function, like basically the function that I'm going to use is X and Y. Okay? Yeah. Set B, and so I'm going to say, okay, so let's say P, Q, R, S, and T. Fine? Okay. So in set A, I have 4 elements. In set B, I have 5 elements. Okay? So the first statement is saying that every element in A has mapping. So the mapping means they should have. So that every element should have a function. Like they should be connected with someone. So they should have a connection with the other set. All the elements, and this is compulsory, okay? And the second one is saying that they should have, like, in every element in A has a unique mapping, a different mapping. So, what if I say, first, according to the first statement, that let's say that, okay, this element's going right here. This one's 2 going right here. This one's going right here. This one's going right here, okay? Is it alright? Yeah, made it a little confusing, but really, trust me, it will be really helpful. Okay, so as I've said that, wait a second. Okay, so according to the first, it is saying every element in set A has a mapping. So every element, like, they should have a mapping. So there's having a mapping. So can I just ask, like, is it a function or sorry? Yeah. Can I just ask, is it a function or not? Is it a function? Is it a function or not? Okay, this is the question. So first of all, like, okay. So first of all, what I'll say is that, let's say that the first element we have is 1, okay? In the according to the B set B, we have P. So what I'll say that what relation are they making? So first of all, let's see, 1 to the P, 2 to the P, 3 to the R, and 4 to the Q. Like, this is really confusing. Like, I can't say that this is a relation. I can't. So, but yeah, just let's say, suppose that this is a relation according to this. So, like, two of the elements are going to one element, like so can I just ask, like, is it going to be a function or not? Of course it's going to be a function. Of course it's going to be a function, because you know, one important thing that I want to tell you right now, which is gonna be kind of helpful. Yeah, so in set B, doesn't matter of the elements, that how many elements we're having. Is it 6, 7, 8, 10, 12, 15 or something else? That doesn't matter. But there's one thing that's just permanent, that's compulsory, is that in the set A, each and every element should have a mapping, and they should have a unique mapping. So like they should have a function with someone, like they should have a relation with someone, like each and every element. Okay, it doesn't matter to the set B. Like I can say that S is not having a relationship with any of the sets in set A. T is also. That doesn't matter. I can say it. Yes, it is a function. Yes, it is a function. Why? Can I ask why? Answer is because every element in set A has a mapping, and a unique mapping. A unique mapping. Just have a look. Why? Every element in set A has a mapping. That's it. Doesn't matter to the set B, even if the elements, like even if the oh my gosh, sorry. Yeah, I was saying that in the set B, even if the elements are like, even if the elements are not having any relationship, that doesn't matter, okay? Just the one thing that matters, that in the first set, we must have every element, you know, like having a relationship with the second element. And yeah, one more thing is that if the condition would be like this, let's say 1, 2, 3, 4, and here we had P, Q, R, S, T. So if the P was connected to two of them instead of this condition, like then will it be a function? Will it be a function? No, it won't be, because every element in A has a unique mapping. That's what it means. Like they should have a unique mapping, not the set B. So set B can't wait a second. Yeah. So like this is literally wrong. Like if two elements are going to, no, this is absolutely right. I did something wrong. No, it's absolutely right. It's absolutely right. What I meant was, wait a second. Let me do it again, okay? I'm really sorry. Yeah, let's make it again. 1, 2, 3, 4. P, Q, R, S, T. Okay, this time it will be correct. Okay, so if I'm saying that this is going here and here. This is going here. This is going to Q, and this is going to T. So, will it be a function? Will it be a function? No, it won't be, because that's how, yeah, in this way, the second statement is also correct. So So every element in A has a unique mapping. So they should have a different mapping. Unique mapping means something like kind of like a really different thing, which is like only one. A unique thing, which is like only one in the world. I can say like it's something like that's unique. Unique like it's some kind of different which existed like the earth. Earth is a unique. I can say we can say that Earth is unique. Why? Because we have only one Earth. That's it. So that's like I'm saying to one, considering the one, only the one. So every element in A has a unique mapping. So that's what I meant. So even if one element's not having a unique mapping, this means that it won't be a function. It won't be a function. Okay? Like they should just like two elements of set A can have a relation with set B, but not the one element of set A are going to have the relation with two sets in B. No, that's literally not correct. So they should have a unique mapping. So this is literally incorrect. Only this way is correct. Okay? So that's what I tried to discuss with you. So I hope functions topic is clear to you. So let's take a question before ending this topic. So let's take a small question which I'm going to write here. So what question should I take? I'm going to take a really easy question. Really easy one. Okay. So questions check whether the following relation let's say F as I'm considering to the function, but first I'm going to talk about the relation. I was about to rub it from the duster, but I rubbed it from my hand. Doesn't matter. Check whether the following relation are set A to B and where f of x is equal to y. Okay, so let me write it in a different way. That's gonna be like more interesting than a simple one. Okay, so I'm gonna write it in a little different way. Like it's gonna be exactly same. So, okay, I've written the question actually in a notebook, so I'm gonna be writing from there. Yeah. So check whether the following relation A to B and is a function and set A is equal to the elements 1, -1. Let's see what other elements do we have. Okay, we have 3 and 7. 3 and 7, and one more set B as we have. What elements is it having? Set B having only 3 elements. 1, 9, and 49. Okay? And the function we have is where f of x is equal to Oh, I had the Natasha. Yeah. Yeah, okay, this is going to be in the right way. So, our relation we have, in which we have pairs x, y, and x belongs to set A, comma, y belongs to set B, and one more thing, y is equal to x squared. That's it. So, that is the question. The question is complete. So, let's solve it. So, first of all, check whether the following relation is a function. So, we have to check whether it is a function or not. So, first thing that I'm going to do is, it is saying that y is equal to x squared. So, let me take it in a simple way by just drawing the arrow diagram. This is set A, this is set B, okay? And what should I say? Yeah, in the set A we have 1, -1, 3, and 7. 1, -1, 3, and 7. And then the second set we have is 1, 9, and 14, 9. Okay, just have a look at it. What is it? 1, -1, 3, and 7, and then 1, 9, and 14, 9. Got it? Okay, so how can I check? How can I check that? Well, what relation is it having with whom? So, yeah. So I'm going to do it in a really easy way. So first of all, the relation that is going to be in the pairs, of course, in the pairs. So the first pair that I'm going to say. So if you notice one thing, that is just saying that y is equal to x squared. And this is actually the hint we have got. So y is equal to x squared. So this is going to be our x, and this is going to be our y. Always remember, x is, like it is said, that x belongs to set A and y belongs to set B. And that's what I did. So, but it is saying that y is equal to x squared. So x is going to be the one which I've done these things in the previous video. So, we're gonna solve it fast. So I'm not gonna waste my time on this. So. Okay, so the x on the 1, so it's saying the x is the 1, so 1 square will be 1, which means that 1 will be having a relation with 1 in set B. That's what we're having. This is it. And the -1 square will be +1, of course, as you know, let's say, -1 into -1 will be +1. As you know, this is really common, no need to tell this. So, and the 3 square will be 9. Okay, 7 square will be 49. Simple. As the 7 was the x, so 7 square is equal to 49, and that's what we had. So, can I say this though? Is it a relation? Sorry, of course it is a relation, but is it a function? I said that they're having a relation. Of course they're having a relation, but I'm asking that, is it a function? Of course it is. As we can see then, every element in A has mapping. And the second thing, which is that every element in set A has a unique mapping. The order, it is following this order. So, which is absolutely correct. So, what relation am I having? 1, 2, +1, -1 to +1, then +3 to 9, then 7 to 49. That's it. So what I'll say, what am I going to say? That R, which is a relation, R is a function. That's it. Wasn't this question really easy? It was absolutely easy. Like, nothing was hard and nothing was confusing. And I hope everything was clear to you. So, like, we discussed about function and we did a question also to understand that, like, is the function topic clear to us? And so, that's all for today. And in the next video, we'll be continuing after the relation topic. And maybe we'll do some questions. I'm not exactly sure, but we'll continue this chapter. And so, thanks for watching and have a great day.